I came across a post on the Personal Finance Canada Reddit which suggested that you don't need to buy the fastest internet at home. Obviously, that's intuitively wrong, but is it factually wrong? I'm going to take a deep dive today into my personal internet usage and see if I can figure out what I really need at home for my internet access versus what I just want to have. Ever since I first got online, probably around the age of 10, I've always tried to get the most bandwidth I can get my hands on. My soul has been scarred for life by growing up with slow dial up connections to BBSs and CompuServe. And over the past 30 some years, I've slowly made steps up towards faster modems, ADSL connections, cable based internet. And a couple of years ago, I finally reached the promised land of having synchronous gigabit fiber internet at home. I'm not inclined to backpedal in my lifelong journey for maximum bandwidth just because it costs money. But the question of what level of service I needed seemed like it could be an interesting exercise in applying my engineering skills to figure out what do I really need versus what do I really want. The post on Reddit took a pretty straightforward and reasonable strategy to analyzing the usage patterns to figure out what you needed at home. If you use Netflix, Spotify, and Zoom, you would go to each of those services, figure out based upon their documentation what their network connection requirements are. You would take the largest of one of those services that you have, multiply it by the number of people in your home that might be using that service at once, and you'd have a reasonable estimate of what your need was. And there you go. You need 40 megabit per second internet. Maybe you'd round it up a bit just in case, but you would start with that. It's better than nothing, right? It's not a bad approach. It's probably also better than just buying whatever the most expensive and largest number internet is. But there are a couple elements of it that I don't like. So I'm going to take a little bit of a different approach and see if I can find a little bit more analytical way to figure out what I really need. It's just kind of fun, right? Sometimes it's just fun to dig into things that maybe don't really need to be dug into. Whatever. So why not? What kind of data can we dig up in order to help us make a data-driven decision here? Luckily, I have a data source on my actual internet bandwidth usage, which I can use to analyze here. This is a little map of my home network. The green box here is a home server, which I call ANSI. ANSI runs a system called Prometheus on it, which is a monitoring system. Prometheus reaches out to the router to get network statistics. It uses a tool called SNMP exporter. So here we can take a look at the IF in octets counter. Once Prometheus has this data, it's possible to query the database and compute and retrieve information about it. That's going to be our data source. That's going to give us the information that we need to know about what our actual network usage is in this home, which we can then use to determine what kind of bandwidth we really need. So this is going to be a resource constraint problem. It's impossible to get an infinite quantity of bandwidth. We're always going to have some kind of a limit. If life was really simple, then what we would do is we would just look at our usage. We would look at the most usage that we have over the past week, and we would say, okay, we hit 50 megabits per second Sunday night. So 50 megabits per second of bandwidth is what we need. That's not going to work. That's not a very practical approach. Looking at the maximum allows a single peak to dominate the requirement. So if we looked at 30 days of usage under a line, but we had a 1 minute spike of usage, we would actually end up buying internet for the whole month based upon 1 minute of usage, which would be a dramatic over-provisioning of the amount of network bandwidth that we actually require. So what we want to consider is what happens if we have a spike, and how bad is it if we limit the system below that spike. For a short spike, it's very reasonable to consider that as something like a file download. So in that case, if we're limited here during a file download, what we're going to do if we have that limit below that spike is we're just going to move the bandwidth usage from over here to over here. We're going to make the download take a little bit longer, but we're going to kind of just flatten out that spike if we have a lower limit. That's probably okay if the use case is a file download, as long as we're not doing it all the time. If we were doing that for a few minutes out of the day, it would be perfectly acceptable to lower that limit and flatten that spike, because it just wouldn't have an end user impact, right? I wouldn't care if my download took twice as long if it's just a file download that I don't need immediately. The tool that I'm going to reach for to analyze this is kind of my go-to tool as a software engineer for doing data analysis of this nature. It's a percentile. The 90th percentile of a data set is the value where you can say that 90% of the data points are below that value and 10% of the data points are above that value. So we can calculate a percentile very easily by ordering all of the data points and then choosing the one that is in that position when they're ordered. Here's a quick visualization. There's a bunch of different data points being collected over time. In order to compute the percentile, what we're going to do is rearrange all of these data points so that they're actually ordered by their value. And then we're going to choose the one where 90% of the measurements are below this value and 10% of this measurements are above this value. And that's our 90th percentile. We can choose a 90th percentile, a 50th percentile, a 99th percentile. Percentiles are a really valuable tool because they allow us to get a sense of the distribution of a data set without ignoring the outliers and being mindful of how we're going to treat and manage those outliers. Hypothetically, if we have a 90th percentile value of our bandwidth usage, then we could say that 90% of the time we need that bandwidth usage or less, and only 10% of the time are we going over that. It's easy then to translate that into something that's more directly understandable as an end user. Let's take a 30-day period. And what we're going to do here is we're going to calculate how much 10%, 1%, 0.1%, 0.05%, and 0.01% of 30 days is. If we had a 90th percentile value for our bandwidth usage, then we could say that 90% of the time we need less bandwidth than that value. We can convert that into saying that for 3 days of the month, we needed more bandwidth than our 90th percentile. If we looked at the 99th percentile, the P99, we would say that 0.3 days of the month, we needed more bandwidth than the 99th percentile, and so on and so forth. So these percentiles allow us to say how much delayed or impacted network usage would be okay if we had a lower bandwidth limit. Hypothetically, if we had the P90 bandwidth usage, we could now say that we need more bandwidth than this for 4,000 minutes per month, but it's enough for the remainder of the month. Well, 4,000 minutes a month of having delayed network usage or resource exhaustion sounds like a lot of impact to me as an end user. The P99, we'd be looking at 7 hours in the month that I'd be throttled. That's not unreasonable. I could imagine 7 hours in a month. At the P99.9 or 99.95, now we're looking at less than 1 hour a month. Now I feel, this intuitively feels to me like the kind of range I want to be in. I'm okay with having lower bandwidth and getting some cost savings. If it only is going to affect me for 40 minutes or 20 minutes a month, that sounds pretty reasonable. We want to take our Prometheus data source and calculate these percentiles. Then what we can do is we can choose the amount of time that we're okay with having a resource constraint affect us as end users over a month. Let's say we choose the 43.2 minutes at the P99.9. Then all we'll need to do is look at the bandwidth requirement that we had over the P99.9, and we can choose an internet plan that provides that bandwidth. I'm not going to go into a lot of detail about how to work with Prometheus and get that data out. I'll just make a couple of quick notes here about the process involved. First, we convert the data from a counter into a rate. Then we take the rate, which is going to be measured in bytes per second, and convert over to bits per second for a bandwidth calculation. Then we're going to filter that data to just the counters that are related to my internet access. Then I'm going to take that query and throw it over into Grafana so that I can extract it easily as a CSV file. I'm sure this is easily enough done through Prometheus's API, but this is even simpler. And then pull that CSV file out over into Google Sheets where I can calculate my percentiles. So now I have my percentiles and I can take a look at what my network utilization is. As long as I am okay at the P99.9, which means having some kind of a network restriction impacting my end usage for about 43 minutes per month, then I need 489 megabit per second download and 179 megabit per second upload. If I wanted to squeeze that a little more down to only 20 minutes or maybe only to 4 minutes of being impacted by network resource limitations, then I could go up to 502 or 508 megabit per second download and 286 and 385 megabit per second upload. Unfortunately, that's a shame. I don't see any justification in going with higher bandwidth. I know that from my usage data, obviously I couldn't have seen anything going higher because I don't have higher bandwidth, but I could have seen here like a P90 being around my gigabit usage, which would have suggested that I'm routinely and often being constrained by my available bandwidth. There's no justification like that here. I think I'm pretty happy with my gigabit internet access. There's one facet that's worth a quick mention in this discussion. That's a term called induced demand. I usually hear induced demand in my personal echo chamber when people are talking about building more lanes on a highway. If you build more capacity, people use more capacity. And so when you build more lanes on a highway tends to be busy no matter how many more lanes you add. Bandwidth on my home internet is definitely subject to this. Both in the direction of having more bandwidth causing more usage and having less bandwidth causing less usage. Let's take a look at the simple case of streaming internet video. If I had a bandwidth constraint, most streaming sites will reduce the quality of the video that they send me and therefore reduce the bandwidth requirement. And vice versa, if I don't have a bandwidth constraint, they send me a higher quality video and I use more bandwidth. In the realm of my home internet connection, I think it's fine to more or less ignore induced demand. Unless I found that year after year, I kept requiring more and more internet, that would be a good sign that my own usage might be affecting my own usage. But I've been really happy with my gigabit internet for the past couple of years that I've had it. So I don't see any sign of that's happening. Maybe I'll have to redo this analysis in the future. But it is a good effect to be aware of. If you're a software developer and you give a customer a faster API by giving them more bandwidth, giving them more CPU, by making the API faster to use and improving performance problems, you can be sure that they will use the API more. It can still be the right choice. That can still lead to better customer satisfaction. But you need to be aware in general as a software engineer that whenever you remove a bottleneck in one place or remove a constraint or improve a constraint, it's going to cause induced demand. Usage will change and it will eventually find another bottleneck. It might even find another one very quickly. Thank you for watching. This is a new software engineering and technology channel that I've created, and you can expect to see some more content like this in the future. I'm also going to be doing some really cool open source software development that I'm intending to build in the public as I develop some new technology. And I'm excited for it. I don't know where it's going to go exactly, but I'd love for you to follow this channel, subscribe to this channel, whatever is applicable for the platform that you're on, and join me as I go through this journey. Your input and advice and perspectives on everything I do will be really helpful in shaping this work. Have a good one. We'll see you later. I don't see you. I don't know what that means.